So, what can we learn from an experiment and what can't we learn from an experiment? Depending on the design of the experiment, as in how it's being carried out, we can either say certain things about the population or not. Let's say that in my experiment, let's use college for an example. Let's use forcing people to go to college versus not forcing people to go to college. So does going to college cause people to earn more money over the next few years? An experiment is, for one thing, supposed to involve randomly assigning people to groups. What that means is, let's say that I get 100 people to agree to participate in an experiment about whether going to college causes you to earn more money. If I randomly assign half of them to go to college while I randomly assign the other half, flip a coin for each one, half of them end up going to college, half of them end up not going to college based on what I impose on them. If I'm able to assign them to the different treatments, you go to college, you not, then if I notice a difference in earnings afterwards, I can establish that there is a cause and effect relationship here. The people who were randomly picked to go to college, there was such an increase in money that they made compared to the others that there's clearly cause and effect here. But if I let people pick their own groups, if I study people, that's not really an experiment if I let people pick whether they are going to college or not, because the people who go to college are going to people who decide to go to college on their own volition, they're going to have a whole bunch of possible confounding variables attached to that decision. So if I let them decide, I cannot establish cause and effect. You have to be able to randomly assign people to the different treatments, go to college, don't go to college, being the treatments, in order to establish cause and effect. And then there's another issue, which is, can you establish that the entire population fits these same rules? Let's say that instead of gathering 50 people randomly from the entire population of the United States, I pick 50 people from Swansea, like the graduating class from Swansea this year, and then I study them over the course of the 10 years afterwards, whether they make more or less money after college. Is that the whole population? Did I really get a random sample from the whole population? Let's say I randomly picked, let's say I picked like 20 people, my 20 students this year or last year, who were seniors. Well, then I can't establish that the results, and let's say I do get to impose treatments on them, or not, doesn't matter. Can I assume that what I saw here in my sample is the same as for the whole population? Only if I've taken a random sample, because if, let's say I just grabbed a convenience sample of my own students, then maybe it's something about having been my students that causes the result difference. Maybe it's something about, and it wouldn't apply to the whole population, like the differences I note between those who go to college and those who don't, has something to do with who they specifically are rather than the whole population. Let's say I get them from Swansea. Well, that's not really a random sample, that's a convenience sample. All I can assume is that the same will apply to people from Swansea. Let's say I randomly grab a bunch of people from the graduating class at Joseph Case. Well, that only establishes it for graduates this year at Joseph Case. You can't assume that the same thing would apply across the entire United States unless you did a random sample from the entire United States. It reminds me of this old stupid joke. 3 people are traveling on a train through Scotland, and they notice a black sheep out there in the fields. And the astronomer says, look at that, Scottish sheep are black. And the chemist shakes his head and says, no. At least some Scottish sheep are black. And then the mathematician shakes his head at both of them and says, no. In Scotland, there is at least one sheep, at least half of which appears black from here. The point being that unless you've actually established that, unless you've actually done it properly, you can't establish that it's true about everybody else out there. If you haven't taken a random sample from the entire population, you can't establish that the results apply to the entire population. Unless you've imposed the treatments and decided who gets to go to college and who doesn't, you can't establish cause and effect unless you can randomly assign half of everybody to go and half of everybody not to. But not necessarily half, but part to and part not to. Let's take another example other than college, going to college and earning money. Let's take something more useful and real. Smoking. Does smoking cause cancer? There's been a lot of research on this, and the tobacco companies are still trying to claim that there is no link. And here's their argument. A properly conducted experiment has never taken place proving that smoking causes cancer in humans. Here's the problem. Can you take a random sample of all human beings? Yes, you can. I suppose. You can take a few from each country, you can go through, ask each country for a couple, although it's hard to get a truly random sample, so you can't necessarily claim that it applies to the entire human population. Can you randomly assign people to smoke and non-smoke? That you can't do. I can't demand that, I can't grab 10,000 people and then ask them, hey, we're going to randomly tell you to either smoke or not smoke, and you have to go through with it. Is that okay? Most people who don't smoke will not agree to start smoking for the sake of science. They figure it's dangerous, or they're just not interested, and it's expensive, so they don't do it. You and other people who are told to keep smoking, maybe they want to quit. Maybe some people are told to not smoke. They are smokers, and they won't be able to quit. Or they will have a terrible time trying. You can't randomly assign people, regardless of whether they already smoke, to either smoke or not smoke. And so you can't establish cause and effect. Or can you? Well, scientists have done a bunch of things. First of all, just in terms of observational studies without experiments, they have observed that people who smoke more often get cancer. That doesn't establish cause and effect, though. So then they tried grabbing random samples of mice, samples of other animals. Half of them, part of them they make smoke, part of them they don't. And then they note that the animals who smoke, or the animals who are put in a smoke-filled situation, I don't know if they can make a mouse actually puff on a cigarette, maybe they just fill its environment with fumes. I'm picturing cartoon like Disney mice now smoking. And then they randomly pick half of them to be put in smoke and randomly pick half of them to not be put in smoking situations. And then, because they can randomly assign half of them to smoke, half of them not, they can establish cause and effect in mice. They can establish cause and effect in, cats. Poor cats, given cancer. They can establish cause and effect in other animals. But because that's not a random sample of humans, they can't say that it goes for the whole population of humans. Since they haven't grabbed a random sample of mammals, they can't say that it applies to the entire population of mammals. Basically, a study has never been conducted properly. An experiment has never been conducted properly to establish whether smoking causes cancer in humans. And the smoke, the tobacco industry will continue making that claim because morally, no one's going to force anybody to smoke. Why does the Surgeon General still put warnings on cigarettes? Because they've established it in so many other contexts. Causality in animals, and not random sampling, but observational studies on humans, that it's considered strong evidence, though an experiment has never been conducted. I just thought that this illustrates well what has to be the case to know what. If you only get a random sample of Swanseans, you can establish that that is true about swan seals, if you can establish that, if you can, yeah, basically just these two things. You need to have randomly chosen people in one group or the other to know that there's a cause and effect situation between the two variables. If I can't decide who smokes and who doesn't, or well, if I can't decide who goes to college and I can't decide who goes to college, I can't establish that the cause and effect is actually between going to college and making more money. It might be something else. So yes, those two things are to be aware of those two things. And be aware that when questions ask you, does this prove that blah? These are some of the reasons that you will then be able to say no, because no random assignment.